Okay, Assalamu alaikum. Welcome all. We can start now with the first paper, multi-objective quantum mouth flame optimization for clustering. You can start now, Yasmin.
Okay. Hello, everybody. I introduce myself. I am Yasmin Sousi, PhD student in High Institute of Applied Science and Technology of Sousse, Tunisia. I am member of Regime Group, National Engineering School of Sfax, Tunisia. Today I will present a synthesis of my work called Multi-Objective Quantum Mouth Flame Optimization for Clustering. My presentation is organized as follows. I will start with an introduction, then I will present the impact of the research work and detail the research methodology. After, I will present an experimentation and the result obtained, and I will finalize with a conclusion and perspective. The context of our work is about clustering. It consists of finding clusters in dataset based on the similarity or dissimilarities of objects. The number of clusters is not known a priori. Considering the existence of several internal and external criteria to assess the quality of clustering, it is increasingly necessary to see clustering as a multi-objective problem with conflicting objectives in order to find high-quality clusters partition. Population-based algorithms are often used to deal with multi-objective problems. We will use the multi-objective quantum mouth flame optimization (MOQMFO) as multi-objective clustering optimization (MOQO) algorithm, and cluster validity indices as objective functions. Our algorithm aims to perform the instability problems of traditional clusters method and optimize the clustering, dealing with conflicting objectives and finding high-quality cluster partition. Here, the architecture of our research methodology. As input, we have parameters, objective function, and the data sets. As output, we have the number of clusters, best position of cluster centers, and classified dataset. I will present MOQMFO, and this by presenting the MFO algorithm and the theory of quantum introduced. After this, I will describe the use of this new algorithm in the clustering domain. MFO algorithm proposed by Mirjeli based on the flying mode of mouth while looking for flames. In a given problem, mouth position present actual solution, while flame position present personal best position of this mouth. Each mouth and flame has two characteristics, position and cost. As shown in figure 1, when moving to a flame G, mouth E changes its position using a logarithmic spiral function performed in equation 1. In equation 1, S defines the spiral function. D is the Euclidean distance between mouth E and flame G. B is a constant for establishing the logarithmic spiral form, and T is a random number in the interval -1, 1. The flame position is updated only if the new position of the corresponding mouth gives a cost better than the cost of this flame. Quantum MFO algorithm, QMFO. Quantum theory guarantees global convergence of QMFO and makes mouths more dynamic using wave functions. Two new variables are introduced, G-best and M-best. G-best is the best position in the set of flames, and M-best is the mean best position among the set of flames calculated using equation 3. In QMFO, mouth moves and change its position using equation 5. Phi and U are two random numbers in the interval 0, 1. Alpha is the contraction expansion coefficient related to QMFO, and the new flame G is randomly determined point between the old flame G and G-best. It is the attractor of mouth E. This new flame is calculated using equation 4. MOQMFO is the multi-objective form of QMFO. It combines the feature of QMFO and multi-objective optimization. As objective function, MOQMFO uses 3 cluster validity indices, including E-index, co-index, and team-index. MOQMFO uses the concept of non-dominance Pareto to store the best solution obtained during each generation in a repository. In MOQO domain, The position of moth or flame is presented by matrix with K rows and D columns. K and D present respectively number of cluster and number of feature of the dataset. As shown in equation 6, each line vector in this matrix presents a cluster center CEG. Here is the flowchart of the OQMFO based on 4 phases: the initialization, the optimization, the decision making 1, and the decision making 2. The second and third phases are repeated n time in n equal to max iteration. It should be noted that before generating the MOQMFO algorithm, a pre-processing phase using MFO algorithm based on the total mean distance is performed in order to determine the range of optimum value of K. After performing the processes this phase, the MOQMFO was executed for each value of K. In the end of the the optimal F measure as well as its corresponding base position and value of K were selected. K here present number of clusters. The flowchart of the initialization phase consists in initializing the number of mouth, number of flame, and number of iteration, and generating the initial mouth, flame, and repository members. The optimization consists in updating the mouth and flame position and fill the repository. The decision-making 1 phase, red blocks, consists in selecting the best position with the best cost in the Pareto set solution produced in each iteration. Then calculating the F measure obtained after the classification of the dataset using this best position, which represent the cluster center position. The decision-making 2 phase consists in selecting the best position with the best F measure in the set of measure produced in the end of iteration. MOQMFO was applied over 6 real-life datasets, including iris, cancer, new thyroid, liver discovery, glass, and wine, and 4 artificial datasets, SPH 43, long 1, 20, and 40. The number of instance, dimension D, and number of cluster K of each dataset are defined in table 1. The algorithm was executed with the following input parameters: number of mouth equals to number of flame equals 25. Number of iteration equals 50. F measure is the metric used to evaluate the performances of MOQMFO and its competitors. High value of F measure imply better clustering, and optimal clustering has a value of 1. Result. Figure 7 presents solution obtained by the application of MOQMFO over iris dataset. Figure 7a shows solution presented by circles colored in red and white. The red are the non-dominated solutions that present the set of Pareto optimal solutions, while the white are the dominated solution. The solution from the red solution is detailed in figure 7b, where we observe the iris dataset presented in 3 dimensions space and divided into 3 clusters: red cluster, yellow cluster, and the blue cluster. The comparative clustering result of MOQMFO and related heuristic based on F measure and number of clusters are shown in table 2. Last column in the table, colored in red, shows result related to MOQMFO. We can see that MOQMFO detects the real number of clusters with all datasets and reach the optimal value of measure with iris, neophy, liver discover, wine, and all artificial datasets. As conclusion, we can say that the proposal showed interesting and comparative results compared with other algorithms. More investigations are under development with other extended and large artificial. Our perspective in this subject consists in improving MOQMFO performance over glass dataset and testing the algorithm over other large datasets, introducing other new technique for the MFO algorithm, and finally using other cluster validity criteria as objective functions. Thank you for your attention.
Okay, thank you. And we can, anyone can ask at the end of the session. Okay, now the second participant can start. Now we have another one with the title of On Optimizing the Visual Quality by Khalid Izzat.
Hello there.
Assalamu alaikum.
Walaikum assalam.
Okay, now you can start, Khalid, on optimizing the visual quality paper. Yes?
Yes.
Okay. You can start now.
Okay. Okay. Hello there. I'm Khalid Adil. I'm here to represent the optimizing the visual quality of HASM-based streaming in high definition or ultra high definition videos. First of all, my agenda is based on first introduction, mesh-based method, mesh generation, three-step search. That's the main topic, and sequences, results, and conclusion. Okay. First of all, that's a typical encoder decoder system, which takes a raw video sequence and convert its format, followed by DST and quantization, and in parallel with a motion estimation, then to VLC and generate a bit stream. Okay. The main part that we are going to talk about this session is the motion estimation techniques in reducing the video size. Okay. The main goal of the encoder decoder system is to reduce or to compress the video sequence or the video file that you have to able to stream it over the internet with the same visual quality or the statistical quality with reduced file size. Okay. First of all, the mesh-based method, the mesh definition is the surface that's constructed out of a set of polygons, which mainly used in computer games or 3D graphics. The first step is just to apply a mesh on top of the video frames. How you generate a mesh? You have three ways to generate a mesh: the uniform hierarchical mesh, the hierarchical adaptive structured mesh, the hierarchical adaptive merge split structured mesh. The two ways or the two approaches that are adopted in this research was the hierarchical mesh, the uniform one, and the hierarchical adaptive structured mesh. Okay, that's the generated mesh that applied on top of every video frame. Okay, we applied this mesh to split the video frame into smaller blocks. Usually it uses 8 by 8 blocks or 8 pixel by 8 pixel blocks to split the video frame into blocks, and then estimating or tracking the motion it happened in which block. If you have any question, just feel free to stop me and ask me. Okay. This is a typical video frame. This is an image took from a video, and this one is the mesh applied to this particular frame. Okay. This is the second type of meshes, the hierarchical adaptive mesh structure. You can see here, or you can notice that the first block, here is the blocks is not 8 by 8, is 512 by 512. You can see here that the first block detected no motion, so it didn't split in that particular block. The second one has no motion, didn't split further. The third one is splitted into 4. You can notice that the motion is mainly around the wolf, whereas the wolf has scattering drops of water around him. Okay, so it detects the motions by somehow an approach, and splits this block into further smaller blocks to detect or to track the motion accurately. The motion detection or the motion estimation that we used in this research was a 3-step search. Okay, The three-step search mainly based on the minimum sum absolute difference to detect whether there is a motion or there is a difference between that frame and the following frame with the search region of from -7 to +7 in each direction. Okay, there are three or four three-step search algorithms adopted. The first one is the original or the ordinal three-step search. It is the basic one that everyone has been using. The leap three-step search, grid, and diamond. The idea of the ordinal three-step search, I can't find the annotation, but I can continue. Okay. The idea behind the ordinal three-step search is that we have our block in the center. That's the middle blue dot in the graph on the top left graph. We have our block in the center. We're trying to find that block 4 steps away in each direction from our block. Okay, so we are moving to the right 4 steps, to the top 4 steps, left and bottom 4 steps. Okay, just those are the 4 candidate blocks that we are trying to find where is our block has moved to. Okay, and we calculate for the 4 candidates the minimum SAD or the minimum sum absolute difference. With the minimum one, we are defining that's our candidate block or the estimated block or the estimated location to be our block. Okay, if we selected our candidate block, which is the right one, the one on the right, which color is blue, further we are generating 4 more blocks, but in the region of 2 pixels away from the candidate, calculating again the minimum SAD and see which has the minimum SAD to be our exact match with our block. Okay, so it calls 3-step search. It searches for our block in 3 steps. The first one generating 4 and searching with the search region from -4 to 4. The second step is decreasing the search region to be from -2 to 2, and third one is 1 pixel away to search for our block. The leap step search is the same as the ordinal step search, with the minimum difference is that it searches for the block not just by moving 4 steps, it moves 8 by 8 pixels in each step. So in total, it will be the first step in 3-step search, and leaps 3-step search would be 32 pixels away from our block. The grid 3-step search is based on the ordinal step search. Instead of generating 4 nodes or 4 blocks to search into, it generates a grid of 8 blocks in every step. And the diamond is the same as the grid. Instead of generating a block of a triangle, it generates a shape of or a grid of a diamond nodes. Okay. Moving to the sequence have been used. We have tested 6 sequences. We have put a sample in this presentation. The first one was called beauty. The second one called shake and dry. The algorithm was applied to the first 5 frames of every video sequence at a fixed mesh and adaptive mesh in 512 pixel as a fixed and 512, and splitting furthermore to a 32 in adaptive mesh structure. Okay, and the results for the 4 algorithms was the ordinal 3-step search has the best PSNR, which is the peak signal to peak signal noise ratio, which is a statistical ratio or statistical measurement for the visual quality. And the ordinal step search is ahead on top of every other algorithm in fixed and adaptive mesh. And the worst one was the leap 3-step search, because it assumes that there is a rapid change or there is a rapid movement on a video sequence or there is a fewer frames in our video sequences, which is not happens to be here. Okay, so the best one is the ordinal 3-step search and the grid 3-step search based on the PSNR. Okay, you can find here, you can notice something right here, that the fixed mesh always less than the adaptive mesh. Okay, so if you set your mesh to a fixed, you will not achieve the best quality. If you are adapting the adaptive hierarchical mesh structure, you will attain more visual quality. Okay, so here motion estimation is our conclusion. Here motion estimation is critical in defining moving objects and frame difference. The comparative result shows the ordinal 3-step search is the optimum solution compared to other motion estimations, which empowers by using the hierarchical adaptive mesh structure, it can achieve the minimum computational cost. That's the first point. And second point, it obtains the highest visual quality or the highest statistical quality. I'm done by now. If you have any question, just feel free to ask me.
Okay, thank you, Khalid. As we have to restrict with the table of all.
Okay, thank you.
So, okay, we will back to you again, Khalid and Yasmin, and all of you. At the end of all, at the end of all presentations, 6 presentations, I will ask all of you. Okay.
Okay, thanks. Thanks.
Okay, thank you. Now the third one. The third paper titled Optimization Algorithm for Photovoltaic System by Mustafa. Mustafa, are you ready?
Yes, you hear me?
Yes, yes, I hear you. Okay.
Yes, can I start now?
Yes, you can start now.
Okay, so hello everybody. Today I'm going to talk about one of the important subjects nowadays, which interests both the manufacturers, research, and scientists, which is renewable energy and exactly photovoltaic solar energy. So as you know, many researchers and scientists now are focusing on the optimization of photovoltaic energy, its emulation and its study in order to contribute to sustainable development and reduce greenhouse emissions. So our contribution consists of optimization algorithm for photovoltaic systems under non-uniform climatic conditions in order to extract the maximum of power from PV energy. So as a summary, we will start with an introduction. After, we will describe the PV field under partial shading conditions. We will also present the architecture of our system, the control strategy of global maximum power point tracking, and we will show some simulation results using MATLAB simulating software and discussing conclusion finally. So as an introduction, the maximum power point tracking is an algorithm implemented generally in photovoltaic inverters to continuously adjust the impedance seen by the solar array to keep the PV system operating at the peak power point of the PV panel under varying conditions like changing solar irradiance, temperature, and load. So as you see here, we have the PV array, which can be a PV field with different PV modules. We have the power converter, which can be either a buck converter, boost converter, split converter, etc. We have the load, which can be a battery, accumulator, or resistance. We have the voltage and current sensing and the MPPT algorithms when generates the duty cycle, and this duty cycle is given to the PV, to the pulse width modulation generator in order to deliver the control signal to the power converter. So we see here we have the characteristic of our system, which is based on a power voltage characteristic. So this power converter characteristic present a maximum power point region and with no maximum power point region. And the objective of this algorithm is to attempt this MPP region in order to extract the maximum of power. We have here the photovoltaic characteristics under no uniform weather conditions. So as you see here, we have 3 PV modules. The first case is under uniform irradiance, and the third case, the second case is under partial shading conditions. So as you see here, as a result, we have the power voltage characteristics and the current voltage characteristics. In the case of uniform irradiance, we have one unique global maximum power voltage, and at the case of partial shading conditions, the power voltage characteristic exhibits and presents a local maximum power point and the global maximum power point, which cause a huge problem of MPPT algorithms in order to track the global maximum power point. So here we have the system description. So the architecture of this system is constituted of the PV solar field, which constitutes of 4 PV modules. We have the DC-DC boost converter and the load, which is based on the resistance. Here we have the global maximum power point algorithm, which is based on modified perturb and observe technique. The conventional perturb and observe algorithm. So as illustrated in this flow chart, we have the flow chart of the conventional perturb and observe algorithm. But the problem of this algorithm is under non-uniform climatic conditions. So when the variation of irradiance or temperature occurs, this system fails to find and to track the global maximum power point and track only the local maximum power point, which causes power losses in the system. So to handle this problem, we have proposed a new modified perturb and observe algorithms for tracking the global maximum power point. So the proposed MPPT, as shown in the flow chart on right, tracks the global maximum power point rather than the local maximum power point and optimizes then the functioning of the system, unlike the conventional existing techniques such as incremental conduction, fraction, voltage constant method, which track only the local maximum power point and produce the power losses in the solar system. So the main idea of this algorithm is to reduce the boundaries of searching the MPP points and without sweeping all the characteristics, which reduce the consuming times of the algorithms and which not burden the processor. And this algorithm is able to track the global maximum power point and to boost the efficiency of the PV system. Here we show some simulation results using MATLAB simulating software. So as you see here, we have the 2 cases. We have the global maximum power point where we have only one local maximum power point, and the second case where we have 2 local maximum power points and 1 global maximum power point. And the power here, we have the power extracted from the PV system. So as you see here, we have 300 watts for the first case and 550 watts for the second case. So our system presents good performances in terms of accuracy and in terms of tracking speed, and is able to track the global maximum power points and boost the efficiency of the system. As a conclusion, the simulation results using MATLAB simulating software proves that the developed global maximum power point tracking algorithm circumvented the problem from which many existing MPPT techniques suffer. It's allow extracting the maximum power from the PV modules even under partial shading conditions and improve the performances of existing algorithms in terms of accuracy and tracking speed. As prospects of this study, we suggest or we expect further work that will be dedicated in the experimental validation of the proposed method and the interconnection with the solar inverter, as is illustrated in this figure, where we have the DC output with the battery and the AC output with the solar inverter. Here we have some references, and thank you for your attention.
Okay, thank you, Mustafa. Thank you. Okay. Now we have another one. feature selection technique based on particle swarm optimization algorithm. Yes, you can start now.
Hello, do you hear me?
Yeah, I hear you.
The slide. Do you see the slide?
Yes, the slide also, it's appear, yeah.
Thank you.
Yeah, you can go on.
Well, hello everyone. First of all, I would like to thank the organizer for accepting my work that I will present. My name is Brahim Etbnali, PhD student in the second year under the supervision of Prof. Nabil Ashfoubi from Faculty of Science and Techniques, Hassan First University. So today I'm going to talk about feature selection technique based on particle swarm optimization algorithm for Arabic name entity recognition on social media. For that purpose, we are going to adopt the following plane. We will start with a general introduction to the subject. Then we will present NIR and its application and its challenge. Then we will present the methodology and the result obtained. And finally, we end with the conclusion part. With the emergence of social media, a large volume of data as produced is becoming the focus of research attention to build the system in different fields able to treat this amount of data to retrieve the relevant information. Among these systems, we can mention name entity recognition. The recognition of name entity, such as person, location, organization, has emerged as one of the main tasks in natural language processing. It aims to extract useful information from unstructured text data. As you can see here in this example, name entity recognition aims to find and classify name entity in text. NIR tools were initially based on text from traditional information, such as newspaper and news agencies. However, with the emergence of the internet, news source of information have emerged, such as social media. Why NIR is important? In information retrieval, most of requests received by search engine are name entity. In question answering, the answer to the question are frequently called name entity. In machine translation, name entity are often translated in a specific way like other words. In navigation systems, a point or a point of interest, also known as a waypoint, are name entities stored in a database with their geo coordinates. Most NIR systems use either rule-based or machine learning or approach or hybrid. The rule-based approach relies on human expertise to mainly build the system models. The systems are often presented in front of a form of contextual rules capable of detecting name entity. In machine learning approach, the rules for extracting name entity are based on statistics and are extracted automatically. Generally, the acquisition of these rules is done from a large corpus. To take the advantage of benefit of both methods, the hybrid approach combines the rule-based approach and machine learning approach. We applied our system to Arabic language. Arabic is known by United Nations as one of the world's main language. There are three kinds of Arabic language are available. Classical Arabic is the language of the Holy Quran. Modern Standard Arabic is language of official document, newsletter, and education. The dialect Arabic, the language which people use to communicate daily. NIR is more challenging when applied to a Semitic language like Arabic due to some characteristics such as lack of capitalization, which is a strong indicator of name entity in language, agglutination. We have some suffix and prefix attached to the word, absence of short vowel. Words are written in the same way, but they are different in a context like Qatar. Spelling diversity and transliteration, we find different hard writing for some word, but they all mean the same word, like Surya. Lack of linguistic resource, that is a huge problem that we face when apply near in Arabic language. Near in social media for Arabic can add other challenge, such as microblog are often characterized by informality of language, the ubiquity of spelling mistakes, name entity are often abbreviated, tweet may contain transliterated word like lul or a no Arabic word, particularly hashtag. We apply filter selection method based on super vector machine particle swarm optimization to find the optimized filter set. Filter selection as one of the techniques used for demosaic reduction, in which relevant features are selected and irrelevant and redundant features are eliminated. Reduction in input demosaic can improve performance either by decreasing the learning speed and the complexity of the model, or by increasing the generalizability and accuracy of the classification. The pseudocode that we adopt is shown in this figure. Now let's get down to experimental results and discussion. In order to experiment our methodology and make our result comparable with the previous work, we use a training and testing dataset provided by Darwish in 2013, which contains more than 5,000 labeled tweets. In our approach, we propose the following feature: lexical feature, the surrounding of the current word, the contextual feature for character, suffix, and prefix, the gazetteer's person, location, and organization, part of speech, tag of each word, morphological feature like genre and proclitic, person, etc. Word tvec, cluster ed, the cluster of such word. Brown clustering is a chain of each word, and finally word tvec is word embedding of each word. The proposed approach is based on 5 main steps, as illustrated in this figure. The first step is related to the data to be used in the experiment, in which a Darwish dataset is used for this purpose. A transformation task to normalize and segment the data into the form suite table for processing in the second steps. The third steps is to retrieve features from the transformed form of data. The fourth steps is consist of our contribution in this study, in which feature selection is performed on the extract feature to select the best combination of characteristic. And finally, the fifth steps is associated with the classification process, in which an SVM classifier is used to classify the name entity. To know the performance of a given system, it is necessary to calculate precision, recall, and F1 or F score. Precision equal true positive divided by true positive plus false positive. Recall equal true positive divided by true positive plus false negative. And F score is an harmonic variable that can be calculated from precision and recall. The objective of this evaluation was to determine the ability of the proposed approach to address the colloquial Arabic text used on Twitter. In order to study the effect of the filter selection using SVM PSO, a two-step SVM was used. The first using the unoptimized filter set produced from the SVM PSO, and the second experiment is the SVM was implemented with all features. The evaluation was carried out using common information retrieval measure like accuracy and recall and F score. As shown in this table 2 and 3, the use of the SVM with PSO outperformed the SVM with all feature for all class. We performed many experiments representing the combination of several models and architecture to understand their effect on the Arabic news system over social media. Table 4 presents the funding of this experiment. This system is being compared with three other models, such as Darwin 2013, Ayazirikli 2015, and Chadihilu 2019. The experiment showed that the considerable increase in the overall performance of the system was observed by using the combination of filter selection based on SVM-PSU, which yield an improvement of 6 points in the F-score. As shown in this figure, it summarizes the result for our system compared to the overall state-of-the-art system that exists in the literature. As a conclusion, we have evaluated the efficacy of filter selection approach in Arabic near task. In our experiments, we concluded that the reduced filters outperform the full filter set. SVM-PSU is well known to achieve considerably better classification accuracy than SVM with no filter selection or SVM based on filter type scheme. We have some reference here based on. Thank you for your attention. If you have any question, please send me an email or thank you.
Okay, thank you, Ibrahim. Now we have to move with another presentation. We have a rough sets cross search algorithm by Mohammed Salim. You can start, Mohammed.
Hello.
Yes, I'm here. Huh?
Hello, welcome. My name is Mohammed Salim, master degree student in mechanical engineering. I'm presenting you today a part of my master degree investigations entitled Roth Sets Cross Search Algorithm for Inverse Kinematics, supervised by Professor Nizar Rokbani and Professor Muhammad Ali Terras. Following this plan, we're going to start with an introduction to answer the question why heuristics for inverse kinematics problems. We're going to then present Roth Sets Cross Search algorithm for inverse kinematics and showing some sample experimental investigation, and we're going to end up by conclusion and a perspective. First, what is forward kinematics? To answer this question, we choose two simple mechanical system. The first system is a robotic arm with 3 parameters. To determine the position of the end effector, we need the 3 parameters Q1 and Q2 and Q3, which are the angles of the links. The same thing for the diff drive. To determine the velocity, we need the angular velocity of the wheels. That's forward kinematics. From parameters of the system, we get the position or the velocity as an output. But the forward kinematics is not helpful in practical usage systems, because we generally need the opposite. We need to we need to set the position of the end effector, and from that position determine the right configuration that enable us to get the right position. We define this definition by this block. From the position, we get the parameters as an output. The problem is inverting the nonlinear equations of the forward kinematics is generally difficult. That's what urge us to use heuristics algorithms. The importance of heuristics in inverse kinematics are simple iterative operations, low computational cost, fast calculation, precision of results with respect of the calculation time. In general, the Roth-Crow search algorithm is a hybridization between the Crow search algorithm and Rath-set theory, Rath-set search. It is essentially known by calculating in the Crow search algorithm. We calculate the Rath intervals to generate new positions in these new intervals and decrease the size of the search space. Solve the inverse kinematics using CSA. In inverse kinematics, such Crow stands for a vector Q, which is a vector of the parameters of the system. The objective function in inverse kinematics is defined by the distance between the target location, xt and yt, and the position of the end effector. It is tested in each iteration of the algorithm. In the experimental investigation, 3 models are used. The first model is a computational model. Consists of a 7DOF, 7 links, 2D manipulator. The second is a 7DOF, 3D manipulator. And finally, an industrial robotic arm, KUKA KR5. The forward kinematics of the first model is shown, as well as the expression of the fitness. There is a sample solution for inverse kinematics using RCSA for a given target point 0 set 04. This graph shows the right configuration to get the end effector in the target location 07 and 04. This is the evolution of the fitness function while processing in 100 iterations. Now we move to the second experimentation, the 7DOF degree of freedom spatial robot manipulator. Here we have the Dinavit-Hartenberg table. This is useful to get the forward kinematics and by consequence the error of the end effector of the robot between the end effector of the robot and the target location. Following these steps, here we have homogeneous 4x4 matrix, and from this matrix serve to transform the coordinates from frame I to frame I+1. Then we move to this equation below, T06, serve to get the matrix which serves to get the coordinates Px and Py and Pz of the end effector towards the fitness function. So we test this fitness in each iteration. This is the solution for LK using RCSA given target point PT080107. We give the solution configuration and the error value is given. Then we move to the evolution fitness function while processing 100 iteration. We can observe that the fitness is equal to E minus 16. Now we test by giving 100 random generated points. This is the stability of the error in different points. Finally, the third experimentation is for KUKA. The same steps as we did in the 7-link systems. Here is the solution and the configuration and the error value. This is the fitness while processing in 100 iterations. And finally, a comparative results between CSA, QPSO, quantum PSO, PSO, and normal CSA. Conclusions. Obtained results showed that RCSA is a fair solver for inverse kinematics, especially when compared to PSO algorithm and CSA. They showed error values that are very precise millimeter range mechanical operation, like welding for KUKA, for example. More investigations are needed to better understand the impact of RCSA parameters on the quality of the inverse kinematics solution. Those are references used in this investigation. And thank you for your attention.
Okay, thank you, Mohammed. Thank you. Now we can move to the last paper.